Hello friends, welcome once again back to the Mixing and Agitation unit number 6 of the Particulate Technology course. So you know that this is our second class in the 6th unit. So in the first class you learnt the basics of mixing and agitation, the principles, and what are the different purposes of carrying out agitation. Then we studied the structure, the construction of a agitated vessel, and we importantly the structure of a agitator. So what are the parts of an agitator in general? So all these things you learned in the last class. Okay, so in the last class we understood what is an impeller. Okay, impeller is that part of the agitator which causes the flow pattern, which creates a certain kind of flow pattern in an agitated vessel. So in order to accomplish the required amount of mixing or agitation. So let us now learn about the different types of impellers in today's class. So here we are going to study what is an axial and radial flow impeller, and we also will be taking up the classification of impellers based upon their designs, and uh, in particular we are going to discuss in today's class about the first type of impellers, that are propellers. So what are propellers and how they are constructed and how they are operated. So how to mount a propeller impeller or a propeller agitator in an agitated vessel. So what kind of a flow pattern a propeller impeller creates in an agitated vessel. So all these details you are going to learn in today's class. So based upon the type of flow pattern created in an agitated vessel, there are two kinds of impellers. One is called the axial flow impeller, the other one is radial flow impeller. So what is an axial flow impeller? So axial flow impeller are the one in which the impeller makes an angle less than 90 degree with the shaft. So that means it is not vertical or perpendicular to the shaft. It makes some angle less than 90 degree. So these are capable of creating flow currents parallel to the axis of the shaft. So the flow currents will be parallel to the axis of the shaft. So such kind of impellers are called axial flow impellers. So these type of impellers are especially used at very high speeds to promote rapid dispersion and used at low speeds to keep solids in suspension. So these are the two important applications of axial flow impellers. So coming to the other type of impellers, that is radial flow impellers. So these kind of impellers have blades which are parallel to the axis of the shaft. So they generate flow currents tangential or radial direction with respect to the shaft. So that means the flow currents perpendicular to the shaft are created with the radial flow impellers. So such kind of flow currents are called radial currents. So that is the main characteristic of radial flow impellers. So these are used for large scale mixing of solid and liquid. So comparatively, radial flow impellers create a vigorous agitation. So they are used for large scale mixing or agitation of solid or liquid suspensions. So this is how we can diagrammatically show the axial flow and radial flow kind of a flow patterns. So you can see the radial flow here, the fluid streams are diverted or pushed towards the wall of the vessel, and there the stream gets separated into two portions. One flows in the bottom portion, flows towards the bottom of the vessel, then there it spreads radially, ultimately returning back to the impeller. So the other portion, after moving towards the wall of the vessel, will flow or gets distributed in the upper direction, and after that it finally returns to the impeller. So such kind of flow currents, if they are generated, they are called as radial flow currents. So as I said initially, so this type of impellers can create flow currents that are perpendicular to the axis of the shaft. So now in the bottom portion of the diagram, so we can see how an axial flow is occurring. So here the impeller is pushing the fluid stream towards the bottom of the vessel. So after reaching the bottom, it spreads outwards and then gets deflected to the top of the vessel, then again returns back to the impeller. So the flow current is in the vertical direction. So the such flow currents are parallel to the axis of the flow. Hence they are called axial flow impellers. So another diagram showing you what is the difference between an axial flow and a radial flow. So this is another diagram showing you the axial flow current and the radial flow currents. So you can see here, this is the impeller blade. So driving the liquid downward, which there spreads towards the wall, then moves towards the top, and ultimately it returns to the impeller. So but in a radial flow, the liquid is pushed towards the wall of the vessel. There it gets separated into two portions. One portion moves in upward direction, returns to impeller back, and the other portion moves in downward direction, then again spreads and finally returning back to the impeller. So now let us see another way of classifying the impellers. So they are broadly classified according to their design as propellers, paddles, and turbines. So this kind of classification is based on the structure of the impellers. That is how they are constructed. So here propellers and one type of turbine called pitched blade turbine are the one which create axial flow. So they are called as axial flow impellers. Whereas the other impellers such as paddles and the other types of turbines are the radial flow impellers. So like the way you have various kinds of turbine impellers like a flat blade turbine impeller, curved blade turbine impeller, then disc flat blade turbine impeller. So these are the ones which are capable of creating radial flow. That is radial flow pattern. So let us now understand in detail about propellers. So as you all know that propellers are axial flow high speed impellers and it is more suitable for low viscosity liquids. So there are different ways of mounting a propeller in an agitated vessel. Either it can be mounted at the center or off center, that is away from the center, or it can be mounted with an inclination at a certain angle to the vertical axis. So this is how we can use the propeller impellers. So coming to its construction, we can say that it is a simple type of impeller or agitator and it is easily portable. The diameter of this impeller, so this is the diameter of the impeller, may be between 15 to 30% of the diameter of the vessel. So those are some of the constructional details for a propeller impeller. So this is a figure showing the type of blades that we see in a propeller impeller. So these two figures show how you can mount a propeller impeller. So the ideal way to mount a propeller impeller with an off-center mounting or with an angular mounting. That is at a inclined position. A typical propeller is shown in figure A. So that one was shown in the last slide as figure A and in this slide it is actually figure C. The most common propeller is a standard three-bladed marine propeller. So this is the most common type of propeller we usually see in use in industries. So it is a three-bladed propeller and the blades are having curved shape and they are called marine propeller. So because they resemble propellers that are used in ship, so which are driven by the force generated by the ocean currents. The propeller is shaped with a tapering blade to minimize the effect of centrifugal force and produce maximum axial flow. The reason for having a curved shape to the blades of the propeller is to create the required kind of flow pattern. So propeller are axial flow impellers. So wherever you desire an axial flow within a liquid mass, so such kind of impellers are used. So due to its curved shape, the propeller blades minimize the centrifugal force effect on the liquid. So thereby maximum axial flow can be created. So with this kind of design. So the last figure, figure D, shows one method of mounting the propeller. So you can have the propeller entering from the side rather from the top of the vessel. So this kind of mounting is especially useful. So whenever you have to suspend heavy particles in a liquid. So the particles are likely to settle at the bottom of the vessel. So that can be rightly agitated with this kind of mounting of the propeller agitator. So you can see how the flow current is created in this kind of installation. So here the propeller is driving the or pushing the liquid so that the liquid is first pushed towards the right side. So if it is entering from the right side, the liquid portion is getting pushed towards the right part of the vessel. Then there it is getting diverted by striking the wall and then creating a flow pattern like this, and finally returning back to the suction of the impeller. So small propellers rotate at full motor speeds, whereas the large one rotate at 400 to 800 revolutions per minute. So these are the operating speeds of the propellers. So propellers may also be mounted near the bottom of the cylindrical wall of the vessel as shown in figure D. So for blending low viscosity fluids and also suspending slow settling sediments in a very large tank. So anyway, this kind of mounting has a drawback because here you need to make a hole to insert the propeller shaft. So there comes a joint which may lead to the leakage. So anyway, so this kind of mounting is a right one for blending low viscosity fluids or suspending slow settling sediments in our large tanks. So this figure shows you how an axial flow current is created by a propeller. So propeller drives the liquid straight down to the bottom of the vessel. At the bottom, the stream spreads radially in all directions towards the wall and finally returns to the section of the impeller from the shaft. Such a flow pattern is shown in this figure. So this kind of flow pattern I already have explained in the previous slides. So here you can see it in the pictorial form also. So this is a propeller agitator and mounting it at the center with the baffles. So without baffles you cannot mount it centrally because that creates a swelling and vortex formation in the agitation vessel. So when this propeller is rotated, it drives the liquid towards the bottom of the vessel. There, after striking the vessel wall, the liquid will spread radially towards the top, then moves till the top, then again returns back to the suction of the impeller. So this is the direction of the flow current that is created using the propeller impeller. So hence we can get an axial flow in a agitated vessel using propellers. Okay, so here are the real pictures of some of the propeller designs. This is a simple design, and this design has some attachments at the bottom, so that is to make it suitable for a particular application. So this is another pic showing you the how the flow currents are created. So an axial flow current in the vessel will be like this. So from the top you can see the flow current in this way. Okay, so this picture shows some of the dimensions for propeller impeller. So this is off center and angular mounting of the propellers. So this is all what you studied in today's class. So we know what are the types of impellers now. So we have two kinds of impellers such as axial and radial flow impellers. So we also know what are axial and radial flow impellers. So axial flow impellers create flow current parallel to the axis of the shaft, where radial flow impellers create a flow current which are perpendicular to the axis of the shaft. Then propellers and turbines and paddles are the three types of impellers, and the propellers are the simple type of impellers used for low viscosity liquids. So they are capable of creating high speed within an agitated vessel. So they can be mounted in different ways, like mounting it off center, mounting it at the center, or mounting in an angular position. So we also have understood what kind of a flow pattern is created by propeller impeller in agitated vessel. Okay, so that's all for today. So in the next class, we will study about the other types of impellers such as the turbine impellers and the paddle impellers. So let us go through a few questions. A propeller agitator produces mainly axial flow, is used for mixing high viscosity pastes, runs at a very slow speed of 2 rpm, all A, B, C. So I hope you can remember what we discussed in the class and get a right answer for this question. So a propeller cannot be used for mixing high viscosity liquids, so option B is not the right answer. So it is capable of running at a high speed, so runs at slow speed of 2 rpm is also not the right option. So when these two are not the right options, then all A, B, C cannot be the right answer. So the right option for this question is the option A, which says that a propeller produces mainly axial flow. So in which type of impeller used in liquid agitation, flow is coaxial? Options: turbine, propeller, paddle, none of this. So axial flow is a main characteristic of a propeller agitator. So the one which produces flow coaxial is the propeller. So below are given a list of agitators employed for liquid agitation in industry and a list of different flow patterns achieved due to agitation. Select the right agitator and the type of flow pattern. Okay, let's have this exercise. So we have two lists. One is the list of propellers, other one is a list of flow patterns. So we need to match the items from the two columns and which is the right kind of matching out of the four options given here. Okay, so let us now check which answer in the right side matches with the first option in the left side, that is propeller. So propeller, it doesn't give any peripheral flow. So axial flow is possible by propeller, with the peripheral circulation is not there. So axial flow is the right answer because propeller mainly creates the axial flow. So coming to turbine. So turbines are radial flow impellers. So option D is the right combination for B, that is turbine. Anchor. Anchor is a type of paddle agitator. So this you are not studied yet. So paddle agitators usually create radial flow currents. So anchor is matched. It can be matched with the option B in the right side, that is peripheral flow. So Archimedes screw with guide cylinder. So Archimedes screw with guide cylinder is a similar structure of a screw conveyor. So this creates an axial flow with a peripheral recirculation. So according to this matchings, I guess option D is the right answer. Okay. Yes. Fourth is the right combination for this question. Axial flow impeller make an angle of dash with the shaft. Is it more than 90 degrees? Is it less than 60 degrees? Is it less than 90 degrees? Is it exactly equal to 90 degrees? So axial flow impellers will not be perpendicular to the axis of the shaft. So they make some angle with the shaft. Usually they make an angle less than 90 degrees. Radial flow impellers have blades dashed to the axis of the shaft. So inclined at an angle greater than 90 degree, parallel, perpendicular, inclined at an angle less than 90 degree. So axial flow impeller will make an angle less than 90 degree. Okay. So here we are talking about the radial flow impellers. So inclined at an angle 90 then less than 90 degree cannot be the right answer, because this is true for the axial flow impellers. Okay. So these will have blades perpendicular to the axis of the shaft. Okay. So the right option is, radial flow impellers have blades parallel to the axis of the shaft. Okay, they create a flow current perpendicular to the axis of the shaft. So option B is the right option. The diameter of the impeller lies between dash of the diameter of the vessel. Okay, is it 40 to 60%? Is it 20 to 40%? Is it 15 to 30%? Is it none of this? So this is a design aspect of a propeller, that its diameter will be around 15 to 30% of the diameter of the vessel. A propeller is shaped with a tapering blade to produce strong circular flow currents perpendicular to the axis of the shaft, produce radial flow, minimize the effect of centrifugal force, and produce maximum axial flow, minimize its fast wearing out. So think and answer which is the right answer for this. Propeller has a blade that is having tapering shape. Tapering or curved shaped blades are used for propeller in order to reduce the effect of centrifugal force and produce maximum axial flow. So all of you know that propeller is a axial flow impeller. So any structure that is given to propeller blades is in order to create that axial flow. So with that, let me conclude the session. I hope you understood all the concepts well. Thank you for listening. See you again in the next class.